Guys, we are on Unit 8, Day 8, and we're going to talk about sine and cosine and their relationship, since you guys can see that they have to have a relationship, since sine is literally in the word cosine. They just put a co in front of it, and we're going to realize that co actually stands for complementary. Okay? And complementary are two angles that add to that add to 90 degrees. Okay. But in the warm-up, it says using the accompanied diagram, find the following. So it looks like three of our trig functions here want us to read from angle R, and the other three want us to read from angle S. Okay, so let's go ahead and read from angle R first. And so we'll have our little stick person up here. Okay? And according to angle R, 15 would be the opposite side, 8 would be your adjacent side, and 17 would be the hypotenuse side. Okay? We'll write down SOHCAHTOA, some old horse caught another horse, taking oats away. Okay? And first one up is sine. Okay? So sine of angle R, and sine uses your opposite over your hypotenuse. So sine of R would be your opposite, which is 15, over your hypotenuse, which is 17. Cosine uses A over H. So cosine of angle R would be your A, which is your 8, over your H, which is your 17. Okay. Tangent of R equals your opposite piece, which is 15, over your adjacent piece, which is 8. All right. All right, now we're going to go ahead and do our next three, which is reading from angle S. And since we're reading from angle S, our little stick person is going to have to move over here. And remember that when you change angles, your opposite changes and your adjacent side changes. Okay, hypotenuse stays exactly where it's been. Since the right angle didn't move, the hypotenuse side doesn't move. Okay. All right, so now they want sine of S. So again, sine of S is opposite over hypotenuse. And so now your opposite side is 8 over your hypotenuse, which is 17. Cosine is your adjacent, which is 15, over your hypotenuse, which is 17. Tangent is your opposite side, which is 8, over your adjacent side, which is 15. And now we have all of our ratios filled in. Okay, and what we're going to talk about today is that these two are equal to the same fraction. And so what we're going to learn is that the cosine of R will equal the sine of S. Okay, and there's another one. These are equal to the same fraction as well, both equal to 15/17, and therefore we can also say that the sine of R is equal to the cosine of S. Okay. Tangents relationship is that their fractions are just reciprocals of each other, and we're not focusing on that today. Only going to go ahead and focus on sine and cosine's relationship. All right. So in this box is a little bit of an explanation. It says in a right triangle, one angle is 90 degrees. The other two angles, therefore, must add up to 90 degrees. Okay. Since the two angles add up to 90 degrees, they are complementary. Okay. Hence, the co prefix in cosine is a reference to the fact that cosine of an angle is or equals the sine of its complement. Okay. So a little bit hard to understand, but what you have to realize, guys, is sine and cosine are always going to be equal when you read from different angles. Okay. So notice sine and cosine of R, those aren't equal because you're not reading from the other angle, you're reading from the same angle. Okay. But when you change the angle, sine and cosine will be equal to each other. Okay. All right. So coming down here, we have to realize that the two angles, okay, have to be complementary. So just to show you guys up here that let's say angle S here was 30 degrees and this is 90, 180 degrees, take away the 90, leaves you with 90, and then take away the 30 leaves you with 60. And so angle R would be 60 degrees. Okay, so you can see that 30 and 60 add up to 90, and that's the whole complementary reference. All right, and sine and cosine will always be equal as long as their angles add to 90 degrees. Okay, and so coming down here, we got a bunch of questions, but they're actually pretty simple if you can just remember that sine and cosine will always be equal to each other if their angles add up to 90 degrees. So determine if the following are true or false. Okay, and so we have sine and we have cosine and we have equal. So far, so good. All we have to do is check that these angles here add up to 90 degrees. And so does 78 plus 12 equal 90? And if you add them together, you do get 90 equal to 90, and so they do, and therefore this is going to be true. The other thing you can do is you can type in cosine of 78 into your calculator, hit enter, type in sine of 12, hit enter, and you should have the same exact decimal, and therefore they are equal to each other. Okay, take a look at number 2. So far we have sine and cosine, so that's good. They are going to be equal to each other as long as these two angles add up to 90 degrees. So does 55 plus 25 equal 90 degrees? And if you add them up, they do not. These actually add up to 80 degrees, which is not equal to 90 degrees. And so this is going to be false. And again, you could try it in your calculator. If you type in sine of 55, hit enter, type in cosine of 25, hit enter, and they are different decimals. Okay. Next one up. Right here we have a problem. That's sine and sine. Its sine is equal to cosine if their angles add up to 90. So in this one, the angles add up to 90, but this shouldn't be sine. It should be cosine. And so this is the reason why this is false. Okay, and again, you could try it in your calculator. Okay, but this should be cosine. Okay. All right, number 4. This one, we do have cosine and sine, okay? And we got to check to see if 13 and 77, does that add up to 90? Okay. And in this one, it does. And so 90 does equal 90. And so we'll go ahead and say true. All right, number 5. We have sine and we have cosine, and they are going to be equal if their angles add up to 90. Well, 90 plus 90 does not equal 90. Okay? But we'll still write it out the way we have been, just to show that this does not equal, and therefore we can go ahead and say false. All right. If you want to check it, again, you could type the left side, type in the right side, both in your calculator, and compare what you get. Okay. Number 6. We have cosine and sine, so that's good. They will be equal to each other as long as their two angles add up to 90 degrees. And 45 plus 45 does equal 90. And so now we can go ahead and say that this one is true. Okay. All right, let's go ahead and take a look at number 7 through 12. And it says find values of the variable that make each statement true. So now we have a little bit of solving in ours. Okay, and so we'll go ahead and take a look. And we have sine and cosine equal as long as these angles add up to 90. So we're going to say theta plus 25 has to equal 90 in order to make this true. All right. If we go ahead and treat theta like a variable, like x, in fact, if you don't like using theta because it kind of looks like a 0 and you get a little confused or harder for you to solve, you can always change it to an x. Okay. We're going to go ahead and subtract 25. And we end up with theta equals 65 degrees. And if you wanted to double check in your calculator, you can now replace that theta with 65 degrees. And you can type in sine of 65, type in cosine of 25, and compare the decimals you get for each one. Okay, but they should come out equal, which makes the statement true. All right, number 8. So again, we have sine and cosine, and they will be equal as long as their angles add up to 90 degrees. So we're going to take theta minus 45 is the one angle. We're going to add it to theta, which is our second angle, and we're going to see if we can get 90 degrees. Okay? Theta plus a theta is a 2 theta, okay? Just like an x plus an x is a 2x, okay? Minus 45 equals 90. Okay. We're going to go ahead and add 45. And we get 2 theta equals 135. And then we're going to divide by 2. Okay? And theta is going to come out to equal 67.5 degrees. Okay? And if we wanted to double check it, we can just come up here, okay, and replace theta with 67.5. If we replace this theta with 67.5 and we subtract 45 from it, we end up with, what is that, 22.5? And so if we take the sine of 22.5 and we hit enter in our calculator, cosine of 67.5, hit enter, you should end up with the same exact decimal. And so we found the right value of theta that makes the statement true. Okay. Again, cosine and sine are going to be equal as long as their angles add up to 90 degrees. Okay. So we took our one angle, added it to our other angle, and we're just going to go ahead and combine like terms. That's 3 theta, often read as 30 because theta looks like a 0. All right, but it's 3 theta plus theta, which would give you 4 theta. Negative 6 plus 8 is a positive 2, equal to 90 degrees. Subtract 2, and 4 theta comes out to equal 88 degrees. Divide by 4, and theta comes out to equal 22 degrees. And you could always, again, check it if you wanted to. Okay. One common mistake is that you guys will set the angles equal because you see the equal sign in the original equation. So just be careful. Remember that the angles, in order for sine and cosine to be equal, have to add to 90. Okay, the two angles can't be equal, although there is only one situation where they are equal, and we actually talked about it in number 6. If both angles are 45 degrees, okay, that is the only time when the two angles are being equal and then add up to 90. Okay, all right, so number 10. We have sine equal to cosine, and so we're going to take the two angles and we're going to go ahead and add them together to equal 90 degrees to make this statement true. All right. 4 plus 46 is going to give us a grand total of 50. We're going to go ahead and subtract 50 to get 40 and divide by 2 and get 20. Okay. Number 11. Sine is equal to cosine as long as these angles add up to 90. So we got 40 minus x plus the 3x equal to 90 degrees. Okay. Combine our like terms. A negative x plus 3x is 2x. Equals 90. Subtract 40. You get 50. Divide by 2, and x comes out to equal 25 degrees. All right, one last one. Again, cosine equals sine as long as their angles add up to 90. All right, so 2x minus 1 plus a 3x plus 6 equals 90 degrees. If we take our like terms and we combine them, we get 5x. Negative 1 plus 6 is a positive 5, equal to 90 degrees. Okay, go ahead and subtract 5. You get 85, and divide by 5, and that comes out to equal 17 degrees. All right, so again, common mistake is that you guys will set the two angles equal to each other because you see the equal sign in the middle of the equation in the original statement. Okay, remember that they cannot equal each other unless they are 45 degrees, 45 degree angles, which you don't know, all right, if they are or not, because you don't know what x is yet. All right, so remember to always take the two angles, the one that follows cosine, the one that follows sine, and add them together to equal 90 degrees to create your equation and then solve for x. Okay, again, if you are unsure if you're doing it correctly, all right, you can always plug your value of x back in. Okay, type the left side of the left side of the equation into your calculator, type the right side, and compare the decimals that you get. Okay, all right, I'll see you guys on the back side of notes for some more practice.